session started this morning. My name is Jeffrey Hengel, and I work in admissions for the Graduate School of Engineering, and I'll be your host today. Really appreciate you taking some time out of your day to learn more about our programs. Our guest speaker today will be the Graduate Program Director, Dr. Kal Bugrara, who's going to be providing an overview of the Computer Systems Engineering program. As I mentioned in the invitation to all of you, that we here at Northeastern strive to provide as much information as possible to prospective students, even before maybe they've decided to attend Northeastern University, maybe even before they apply, so you can make an informed decision about what program is a good fit for you. You joining us today are a very mixed audience. Some of you applied directly to the Computer Systems Engineering program. Some of you are actually admitted for the spring 2018 term. And so for those of you who've already applied and have been admitted, I want to congratulate you on being admitted in a very competitive admissions process. Most of you, though, are applicants to the Computer Systems Engineering program for the spring term or even for next fall. And so if you're a spring applicant, we hope to complete our review process within the next couple of weeks. So if you haven't received your official decision from us, you'll know about that very soon. And then we have a number of other prospective students joining us today. Maybe you applied to the Information Systems program, where Dr. Bugrara is also the Graduate Program Director of that program. We have webinars on our Silicon Valley program, and we have a webinar about the Information Systems program specifically this coming Thursday. So if you're interested in that program, please join us for that too. And then we have all kinds of other students who might be joining who have an interest in this Computer Systems Engineering program. Once again, we appreciate your interest. A couple introductory notes here. We want you to turn off your microphone and your camera. That tends to work best for these webinar-type presentations. I've heard from those who are facilitating the session that the audio is pretty good, so I hope that you're hearing me okay. We are recording this session, and so we will send you a recording of the session within the next couple of days. If you have questions as we go along today, please let us know. There is a chat window that you can use to type questions. Make sure that you send your questions to everyone so that the most appropriate person can answer those questions for you. In addition to myself and Dr. Bugrara today, we have a number of other staff members who are joining us today who can answer a wide variety of questions that are program related to our cooperative education program, and related to admissions. So make sure and use the chat function. Also let us know if you're experiencing technical difficulties or if you have any other problems as we go along. All right, so I guess towards the bottom of my list here, if you applied for the spring 2018 term, classes start in early January. Some of you are already making plans to attend. For those of you who are awaiting your decision, you'll be hearing from us very soon. Most applicants to our programs apply for fall entry. The next viable term of entry for the fall is our 2018 term, where we have classes beginning in early September. Most students will apply by January 15th. You can apply later, but that's where typically most of our applicants apply. Our fall cycle is much heavier than our spring cycle, so it takes us a little bit longer to get your decision to you. One thing that we're mentioning to all of our applicants is that we encourage applicants to examine our entire menu of Master of Science programs. Those of you joining us today are electrical and computer engineers. Some of you studied computer science or other computer-related majors. And so you're actually qualified to pursue a variety of programs at Northeastern. And so if you have interest in more than one program, we encourage you to apply to more than one program. This, we think, increases your chances of success. So you already are interested in Northeastern University. That's why you joined us today. But a couple of things that you might not have known. Northeastern is one of the best national universities, ranked in the top quarter of all ranked national universities in the U.S. For several years now, our current ranking is 39. when I started in my position 8 years ago, our ranking was in the mid-60s. And so the ranking has grown by leaps and bounds, which says so much about how Northeastern University has innovated over the past several years. Ranking has to do with quality of programs, quality of the faculty. It also has to do with our reputation. Part of the ranking has to do with, employers are surveyed and asked about the reputation, asked about the quality of the graduates of our programs, and that's one thing that's considered in our ranking as well. So that's important for applicants to know that they're going to a reputed program. We're located in Boston, as you know, and have been here for over 100 years. This particular slide references telecommunications and networking, but most of our technical companies and technical employers for co-op are also in the Boston area, but our co-op placements are all across the U.S. So Boston's really a wonderful academic community. It's famous for its healthcare systems. It's a really great place to live and to work and to study. So we hope that you join us here in Boston this coming spring. You also know that we have campuses in Seattle, Washington, and now in Silicon Valley. So we're very excited to be able to offer students the opportunity to study information systems in those locations as well. Last on this slide is we talk about our Career Services Office. Northeastern University is very serious about the career success of its students. So those are just a couple of broad statements, but the main part of our talk today will be a presentation by the Program Director of Computer Systems Engineering, Dr. Kal Bugrara. So let me invite Dr. Bugrara to give you an overview of the Computer Systems Engineering program, and I'll conclude with a few notes about our co-op program and a little bit about investing in your education. Just hang on one moment while we get Dr. Bugrara on the line.
Okay, thank you, Jeff. Jeff?
Yes, Dr. Bugrara, I can hear you.
Okay, very good. All right, good day, everybody. My name is Kal Bugrara. I am the Program Director for Computer System Engineering and Information Systems. And my objective over the next few minutes is going to give you a sense of what we have to offer at the software engineering technologies and ideas, methods, and tools. Key aspects. Right, so the program has computer system engineering has over 100 students. It's been growing quite steadily. It's a sister program to an even bigger program called Information Systems here as part of the College of Engineering. Now, the one simple way of looking at the forces at play right now vis-a-vis the need for virtual software, and going digital is businesses are going digital. Digital businesses creating new ways of generating revenues. Small players are chipping away at stable sources of revenue for big players. For example, banks right now are freaking out over these small payment systems that can be done over simple apps. Being nimble and agile is the way to go. So being able to re-engineer the way things are done in these big companies is moving forward right now with tremendous change going on. Of course, in addition, social change can benefit from technology. This applies to governments, either local or nationally or the like. Now, with all these changes, software engineers are at the center of the next revolution. So how do we prepare our software engineers to respond to the tremendous challenges coming their way in terms of how to apply software to address social and business problems? Next. So these are the buzzwords these days: machine learning, big data, virtual money, Internet of Things, robots, virtual assistants, autonomous vehicles, virtual reality, artificial intelligence. And these are the big deal here is the tremendous acceleration of technical innovation that we see right now. Not only we see technical innovation, but the speed at which things are happening is like we've never seen before. You know, I always tell people about the dot-com era around 2000, 1999, where the change was driven by IT. But this particular change we face right now is the business themselves so excited about technology and want to be, of course, the challenge remains, okay, how to apply these technologies in a way that will benefit the business, community, and society. And this is what software engineering is all about. Next. Some of the challenges that companies face right now: huge amounts of data already exist, must be properly leveraged for competitive advantage, new generation of applications that consume the data and produce smarter insights. Right? This is what we call AI right now. And the challenge now is how to build for such gigantic scale, global, multi-enterprise systems, collaborating to get work done. So we not only have the challenge of building more complex systems, but they are of gigantic scale. So scale of these applications matter. A lot of projects that our students work on involve how to build systems that can cross national boundaries. For example, one example will be how to distribute blood supply across national boundaries through the support of applications, how to move vaccine for children across national boundary, and how to build such applications of a gigantic scale. So definitely this is calling for a very complex set of skills: programming, design and architecture techniques, communication, as well as people skills. And these are the things we hear every single day from the industry, the employers that are participating in our programs. This is what we need, and more of the same. So even our graduates are telling me they're not only asking for web development anymore, they're asking for web development, JavaScript programming, and in addition to that, they want machine learning. So there's the set of expectations coming from employers are spanning multiple disciplines. So this creates all kinds of challenges, and I'm going to take you through how are we responding to the demand coming from industry for our students and the way we deliver our instructions. Next. So the need, as we see it right now: user experience design and development, machine learning and data analytics, engineering. You know, so we're not producing statisticians nor mathematicians, but we think of machine learning and data science as an engineering problem, and this is how the program is approaching data science and machine learning. Big data system engineering is a huge need out there. Big data design and architecture, distributed big data databases, Hadoop, Spark, big data schema design, parallel programming, and Scala are the kinds of things people are asking us for, and you will see how our classes are responding to these needs. Of course, the big push right now is on natural language processing, or what we call NLP, and structured data in the form of text or write-up than it is of what we call structured data or databases of some sort. So that intelligence in these text documents have to be extracted, have to be understood, have to be analyzed, and stored in a different kind of in a structured format using things like Elasticsearch and the like, converted index type technology. Cloud computing and virtualization is becoming huge, as you know. Almost everybody now is accepting the fact that there is no point in storing your servers locally anymore. It seems to be safer at Amazon than within your enterprise. After all, everybody is using the same data centers, probably somewhere near the North Pole. Okay, so security seems to be still a big problem for these enterprises, and it does not make sense anymore to maintain your own hardware infrastructure at all. One of my graduates is telling me that it took him an hour to configure a very complex server on Amazon, which would have taken him 9 months to do it internally inside the company. So we are addressing big cloud computing big time in our program. And our students, our graduates are at Amazon working on future cloud computing technology already. And again, there's also more demand for better understanding of algorithms, Java, JavaScript, E6, E7, and now E8. Still C# is important. C++ didn't go away. Scala is the functional programming language of choice these days. Much better programming language for handling big data processes. Haskell is coming to the picture. Old Lisp and Scheme is showing up again in a language called Haskell, which is becoming important for blockchain type legal contract execution platforms of the future. And now the latest is Go. Just yet one more evolution of these programming languages, and the demand for this is quite extensive at the moment. Next. How we address the need, this is really what I would like to spend some time on. Next. All right, so this is our traditional way. We've been practicing software engineering for the last 12 years between information systems and computer system engineering. And we have this philosophy of software programmer. We chose software engineering. We think of software the same way engineers think of systems, that it's the assembly of a number of parts. The whole is a lot bigger than the sum of the parts. And we take our students what that means. We teach them how to think of software application the same way Toyota thinks of a car, that it's made up of subsystems, and there's a social structure around each subsystem. For example, there's a huge ecosystem around the transmission, a huge ecosystem around the motor, and all these subsystems are interacting at the interface level. How to design software in a disciplined way that allow us to handle complexity much more effectively than ever before, especially with the assumption that we have right now, future applications are going to be extremely complex, and software engineers need to be up to the task. And we're addressing these complexities and these challenges head on in the way we do things within the College of Engineering. Right? So we follow a socio-technical system engineering paradigm to solve complex real world problems. We have the incoming class for fall 17, and they're already into the issue of how to design these systems correctly in a very effective way. So we call our technique programming with a purpose. So definitely the benefit to derive all the software engineering techniques we build. And to be a good an acting balance between business complexity, software techniques, programming techniques, and IT management. How could you build anything if you don't understand the concept of cost and time and quality? So, and our students sort of navigate these three different areas, so it will fit them the right way. Our programs are very flexible, and you can veer your career in different directions. The balancing act will be to balance your courses between these three different areas. However, you could choose to be heavily technical. You could choose to have a strong business architecture mindset, or be veering more toward the project management side, which emphasizes community. Who we are between the two programs, computer system engineering and information systems, the emphasis has been on the kind of students getting into each of these programs. The audience that are geared toward computer system engineering tend to be people who want to have a heavily technical program, probably already had some extensive programming experience before, but they are lacking the ability to solve and be able to build complex systems the right way. We take them through those techniques that we have, which we feel are unique in this world. Next, Jeff. So the key courses, so when the emphasis is on the key track right now in computer system engineering minus the combination from information systems, this is the course offering we have for our students. We'll have to get going with the object-oriented design and heavy programming in Java or C++, either one will be fine to start with. Then web development is our enterprise software development class, heavily into Angular 2, Spring, Hibernate, and the like. Network structure and cloud computing. We have an amazing teacher teaching this class. He was part of the original team who worked on the IBM Watson, and graduates of his class multiple graduates of his class are at Amazon, sending me messages that the kind of tools and techniques being practiced there is what's needed at Amazon. Of course, we have the big data system engineering using Scala. This gets into functional programming, which aids in concurrency quite a bit, and the ability to build the Spark type jobs very easy, simply with safety and solid concurrency assured. The multi-threading class, concurrency issues, is another heavy development course that we offer for our students to make sure their ability to deal with the huge volume of users, access what they're doing. Big data systems and intelligence analytics. This gets into deep learning, advanced machine learning techniques. This is linked to another class as part of information system that teaches the fundamentals of machine learning and data science. Gets into classification, Bayesian techniques, clustering, and what have you. But this particular class answers the question, given having taken the big data engineering class and having taken the data science class, now how to push this to the next level, right? To create a project that could involve machine learning, deep learning, and the like. This is what we do in that class. And we have the virtual environments, a huge field that's coming to the picture these days. We taught this class first time last summer. It's been very exciting for our students to learn all the virtual reality frameworks written pretty much supported through JavaScript and the like. So this is a track that's going to continue to grow in our program. So these are the basic classes out of computer system engineering. However, students in this program have access to an amazing information system. Information systems is heavily technical. Information systems at the College of Engineering at Northeastern and Johns Hopkins are the only two programs in the country that are part of the College of Engineering, and both of them are heavily technical. So even information systems, we still think of an information system as a system engineering problem, versus the MIS type approaches that you might see in business schools and some computer science programs where the whole issue is primarily managerial. We don't do that. We would rather build technical engineers that can learn how to be IT manager at some point. Still, we think it's more likely one of our graduates will become IT manager than, say, computer scientist, just because of the software issues that we address in our programs. Next. So this is for semester number 1, what students might want to do. Take the Java programming class, object-oriented, multi-thread programming, introduction to threads and swing programming and the like is all covered first class. It tends to be a little bit slower at the beginning, and students generally take the algorithms class with that as an alternative. Basically some of the classes that you could be doing semester number 1. And if you want to be on the softer side, in addition to a heavily technical program, then you take the user experience design class that emphasize the look and feel, prototype, user interaction, prototyping, best way to build stuff. Our teacher is out of the MIT Lincoln Labs, where he is responsible for the user experience. This is an MIT associated lab that is addressing user experience issues for the U.S. government, and they have strong alliance with IBM as well. One of the key managers there is the teacher of this class for us. Next. And this is overall, I think, if I want to make an offer to you, a value proposition, who we are, whether you are in the computer system engineering program or IS, that our courses are in these categories. We have over 30 topics across these 2 programs that will satisfy the different needs that you have, right? So let's get on with some of the tracks that we recommend to our students, or the guidelines how they should be taking these classes if they want to specialize in each of these categories. Next. So your skill sets in terms of in a certain way. This is one category, big, how to be. So this list answers the question how to be a big data engineer, and I think this is one of the most important areas for our students, where we feel a lot of the data science work out there is being done by mathematicians, physicists, astronomers, and the like, with little knowledge how to build real systems out of the math and science that they're doing. Our graduates deal with the complexity of the data that's needed to make these mathematical models work. And I've been hearing this consistently throughout the industry, that for any machine learning or data science project, over 90% of the effort is into the data engineering side of things. And this is what our students are good at. And they're generally loved by all these data scientists in terms of their ability to put a complete complex pipeline together where you're able to ingest gigantic amounts of data and be able to create the insights you need. And this is the essence of being a big data engineer. And this is a highly sought after area, and this is what we recommend for our students along these lines. Scala development, big data engineering class, big data and intelligence analytics, the concurrency class are all great foundation for these classes. If you couple this with the algorithms class and possibly agile development, you will be in great shape for an effective growth job in the field. Next. Still, the softer side of who we are, user experience design is a very important area for what we do. This is a specialty within the information systems program, but I'm offering this for some of you in case you want to be able to take some of these classes out of the information systems program. And of course, one of the most exciting areas for us right now is the managerial communications class that emphasizes communication for software engineers, the ability to function properly within a team environment and to have effective communication with your managers. And this is a recipe for a growth path to an even better future. Right, next. So this is, if it gets, next, yeah. So this is primarily for people who want to be data analysts, and the recommended area here will be primarily for people who are on the information systems side. Next. So cybersecurity engineering, this is the still part of IS, but it's available to computer systems engineers, is how to build security inside out in the system. That's a very big area right now. Is the best way to handle security, redesign the way we approach software design and development. And this class gets into the heart of that. Getting into distributed security, that's also a big area for us. IT auditing is available, and the focus right now is auditing in the cloud. Natural language processing, this is a class we have. We can emphasize natural language processing even more. And this is important for surveillance and the ability to understand intent out of the text, so to capture the bad guys. So, and again, cloud computing is important there as well. Next. And the mobile class leverages, there's a smartphone-based web development class that emphasizes iOS, sometimes Android as well. That could be of interest to you. Next. Right, and this is the software side. If you are heavily into development already, then planning to build an IT managerial career is a possibility here. And the last class on this list is architecture and governance of big data systems. This is probably the only class that exists in the world that show how to plan big data projects the right way. The teacher for this class built his own project portfolio management tools that the students in the class are leveraging to plan a complete project, from the funding models to the resource management to the schedule and all aspects of the governance involved around these big data projects. And they're using tech tools and very specialized methodology, this worked out by the professor, to learn a new way of taking on the complexity of putting a big data project into motion. Next. Of course, the full stack software development side, this is on the IS side. However, these classes are available to you as well. Next. Machine learning and data science, this is the combination between what we have in the in IS and CSYE, deep learning in the cognitive and neural net computing area, right? Coupled with data science classes and advanced data science and intelligence analytic classes. Natural language processing could add to the mix here as well. These are also available to computer system engineering students. Next. All, of course, right now is our emphasis on blockchain and cryptocurrency engineering. We have 2 classes running right now. That, in addition to the cryptocurrency, we have smart contract application engineering and development class. Extremely, extremely complicated topics. And these classes, we're addressing the issue of how to build the trust in systems when trust does not exist, which has a huge significance in the way business itself is run. So we're taking our students through this revolutionary technology, and we're making headway. And this is actually an area that's going to campus, but it will be the key specialty we have out of Silicon Valley. But the courses might be available in our Seattle as well as Boston campuses. Okay, so whatever it is, these are the offers we have, and I'm proud to tell you, very excited to say that we are our programs are in Boston, Silicon Valley, and Seattle, and sometimes we might even bring a live link of discussions, class discussions over just because of the expertise that we would like to have our students have access to. For example, right now, we're bringing, the plan, we're working on a class, we're bringing an expert out of our Seattle campus in a live link to our students in Boston just because of his expertise in machine learning and healthcare. And the problem that he's working on is he want to And he feels with the advanced big data and machine learning techniques that is within reach over the next few years. That there's so much knowledge, healthcare knowledge already, that we might be able to, machine might be able to diagnose what's needed for a human being. Right? So this is how both things are. This professor is going to be accessible to our students in our Silicon Valley campus as well as our Boston campus, though his presence is primarily in Seattle. So this is, and likely will end up somewhere in Canada as well next year, and possibly the Far East, and it's all one single program and having knowledge accessible to our students wherever the knowledge is. So thank you for listening. I want to emphasize there's something I didn't really emphasize much of, that we are design-driven programs. Lots of passion and emphasis how to build software the right way and how to really build the necessary skills to be a good problem solver instead of a task-oriented programmer. The application engineering and development class that we teach here is really unique. There is nothing like it in the world. The only competing unit that's teaching similar design issues is MIT, and they haven't solved some of the execution problems that we solved here on our campus. They're still struggling to map what they call conceptual design to executable implementations. This is a problem that exists in the IT. They're still struggling with it over here at the Northeastern campus. We are in an excellent shape how to make complex conceptual designs in the form of object-oriented notation or format, and be able to see executable applications in one single mapping, in a one-to-one mapping. The components, and we show people exactly how these components are business-oriented, but at the same time, there's executable application. And literally, our students are learning those methodologies from day one when they join the program. And this allows us to bypass a lot of the programming bug headaches, because with good design, little error, good structure, clarity of the approach, and the ability to use these techniques to handle even more complex applications. And we show our students, how your design can extend horizontally to be able to scale it into multiple regions and cross-national boundaries. Because in our view, future applications are going to be all global, cross-national boundaries. And these are the techniques we're teaching our students. And the more ready you are, the faster you can move through the program. And the fact that we have such a vast array of options for our students, which is unmatched by anywhere in the world, that puts you in a position to really configure your future the right way as you best see fit. Our job is to offer you a platform where you can discover the most effective way for you to be a first-class software engineer. And of course, with Boston, the closeness of MIT, a huge IoT center coming into being next year from GTE, Facebook is here, Google is here as well, and more technical challenges are going to be available to you. And with the program that's really current and in tune with the challenges in growth for yourself. And this is something we see for our students every year as they grow. So we don't address the need based on what companies are telling us. We anticipate what they're going to need and design our courses that way. So you're going to see a lot of the capabilities in our courses to do with things that are coming up. And so when you graduate, you will be ready, and they will be ready for you as well. Okay, thank you.
Thank you, Dr. Bugrara. After this slide that we're seeing now, you have a couple of slides on semester 1 and semester 2 options. Are those slides relevant for this talk, or should we skip those?
I think we're okay for today. I think we got the message in it. Yeah.
Okay, thank you then. for participants joining us today, you now learned a great deal about the Computer Systems Engineering program and a close cousin of the Computer Systems Engineering program, Information Systems. Now you know why these programs are some of the very most popular programs that we offer at Northeastern. And so there's so many options that you can pursue. I'd like you as a participant to start thinking about what your questions might be about the program for Dr. Bugrara. As we conclude our session, I'm going to talk a little bit about our cooperative education program and a couple of slides on financing your degree. But as I'm going along, sort of in the next 15 minutes as we conclude, think about what your questions might be, and we'll do a bit of Q&A with Dr. Bugrara before we conclude our session. So I already see questions coming up, so please keep those questions coming.
So I think one question, Jeff, there about the difference. I would say the biggest difference is in terms of the students coming into the program. They tend to be more technically oriented for computer systems engineering program than for IS, right? There's more passion for pursuing a heavily technical track than you would in information systems. Information systems students tend to like to take some managerial classes with their technical class.
Okay, thank you. Let's continue with a talk on our cooperative education program, and we'll be happy to facilitate some Q&A with Dr. Bugrara more before we conclude our session. I'll remind our participants that we have a variety of staff people that are joining our session today who can answer your questions. We have an assistant director in the program who works closely with students. We have a faculty member who works in our cooperative education program joining us today, Mr. Mike Schwartz. So I'm going to do my best to talk about co-op, but we really have the expert who can answer more specific questions. A lot of students apply to Northeastern University because of the opportunity and the option to pursue a graduate co-op, which is a 4 or 6 or 8 month long full-time placement with industry, where a student is essentially putting into practice all of the wonderful knowledge and skills that they're learning as a function of their program. Students will do this co-op, or successful in getting a co-op, will do this somewhere in the middle of their program at Northeastern. It can extend a student's graduation by a term, at least a term or two, but for many students interested in getting that industrial experience, it's very much worth it. So every year, hundreds of students are placed with industrial co-op positions as part of their degree plan. You can see we have hundreds of relationships with employers. There's an entire staff and faculty network that supports students in their success. Students can earn a significant salary if they get a co-op position. You can do the math on what that salary might be. If you're working for a company 4 months or 6 months or 8 months full-time with an average salary of around $25 an hour, you can see that students can earn a significant salary to defray education costs. We must say, though, that the co-op placement process is a competitive process, so not all students who want positions will get positions, but historically speaking, we've seen very strong placement in the CSYE and NIS programs. So for students who are interested in the cooperative education program, their first step is to register for a co-op preparation course. I'm not sure if the title is still Career Management for Engineers, but that was a recent title of the course. And that is a course that students take typically in their first or second term at Northeastern University. And then after they successfully complete the course, then they can begin competing for positions. So this is really, you know, kind of a philosophy statement that co-op is career preparation. So if you're successful in finding employment, you can be successful in finding a co-op position because it's very much the same sort of career development process. It has to do with your readiness to join industry. It has to do with how well you know yourself, how well you know the kinds of positions and the kind of industries that you want to pursue in your career. And, you know, there are students who are so motivated that they actually create their own co-op positions. But we have a faculty network that assists students in preparing for their search for a position, and they support you in your success. So the whole goal of the co-op program, we know that students can earn a lot of money if they're successful in getting a position, but it's really an academic program at the very heart of things. It's a connection between the academic program, the industrial experience, as you pursue your degree program. So it's a learning tool. So we always mention that co-op is not required. There are some students that want to graduate quickly. They already have perhaps some industrial experience, or they already have the skills to be successful in industry, and certainly not required that they pursue co-op, but many students do pursue it as an option. If they pursue co-op, they'll take the Career Management for Engineers preparation course that's billed at 1 semester hour, so it's a bit of an additional cost in terms of tuition. A quick overview of the co-op course map, if you will, is basically teaching students the elements of creating a job search plan or a co-op position plan, learning all of the tools and techniques to be successful, LinkedIn, strong correspondence, essentially job search skills. You put all of those things together with your own sort of motivation, and you implement your plan, and hopefully at the end you're successful. So it's not only about getting the position, but it's also about being successful once you're placed. So your co-op, the interesting thing to think about when you're thinking about coming to Northeastern University is that not only do you have your faculty and your graduate director who is supporting your success, but you have a huge network of staff and co-op faculty that are there as well. And so your co-op faculty member not only teaches the course, but they're your partner and your coach and your motivator as you go along. There are instances where students don't find positions their first, I guess, their first effort, but they continue to work hard at it. They continue to build skills in their courses, and eventually they're sometimes successful. So moving on then in terms of my next topic, I'd like to talk a little bit about investing in your career. So a student pursuing their engineering master's degree, it's a huge investment of time and money. And so we want to talk a little bit about the investment and the return. The tuition this academic year is $1,523 per credit hour. Most MS programs are 32 credits long. If you pursue co-op, that course is billed at 1 semester credit hour, so that's 33 credits. So you can begin to do the math on what the tuition costs will be. Fees are about $500 per year, and all full-time students at Northeastern are required to have health insurance. Most students participate in the Northeastern University Health Insurance Plan, which is about $2,100 per year. So over the course of 2 years pursuing your degree at Northeastern, you can get a sense for what the cost might be. Sometimes we use a figure of 70 or 80,000 US dollars as a kind of total figure to live and study in Boston for a couple of years. So it's a significant investment, but there's a significant return. I like to make the comparison to the field of medicine and the field of law. Aspiring professionals invest heavily in their personal and professional development so they can get the return of the career that they want, the salary that they want, the development of knowledge and skills. And at Northeastern University, students can also benefit from the vast network that we have with industry, co-op being one of those. Most master's students at Northeastern University pay for their education entirely using personal and family funds. I've seen this year a lot of students taking out educational loans. As we mentioned, cooperative education for students who are successful in getting a position, they can earn a significant salary. I've talked to a lot of our students, and many of them are able to find part-time work as they're pursuing their degree. It's a common question about how many students will be able to find a part-time job. I don't have statistics on that. I can only say anecdotally that a lot of international students in particular that I speak to who ask this question are successful in, or I should say current students are able to find part-time positions. When a student applies to Northeastern, they're actually automatically considered for any kind of tuition scholarships, and each year a few partial tuition scholarships are offered to students, but they go to a very small percentage of our applicant pool. The vast majority of students get no kind of financial support from us. There are students who are highly successful in the program, and they're actually able to be hired as sort of TAs, and they work actually for the program. So there are some opportunities for current students as they go along. But for the most part, other than cooperative education, students don't get any sort of benefit or any opportunity for financial assistance from the university. But we think, once again, that the investment is very much worth it. So we're about 4 minutes before the top of the hour. We want to make certain to get to any questions that you might have about the program for Dr. Bugrara, about cooperative education, or about anything that we've presented here today. So let me turn off my microphone for a bit, and we'll see what sort of questions you have for us in the next 5 or 8 minutes as we conclude our session today.
I mean, there's still opportunity for someone is asking whether that you can still apply for the spring. Yes, you can. So if you want to put an application, go ahead. We might have a chance to take a look at it.
Yeah, I'll add to that and say that technically speaking, the deadline was September 15th, but it's only a couple weeks past then. And we typically give applicants a couple weeks as a grace period to complete their file. So as Dr. Bugrara says, if you apply very quickly, if you've already taken the GRE and the TOEFL, if that's required of you as an applicant, essentially if you have all of the materials that are already ready to go to apply, our application is entirely electronic, and so it should be very quick and easy for you to complete the application. You'd want to do that very quickly, and then we'll do our best to expedite the review of your application for the spring term. I might add that our deadlines are generally flexible. We set those deadlines really for practical purposes to make sure a certain amount of work gets done in a particular time frame. But for international students, the real deadline is the I-20 visa-related process deadlines. So most students will have the ability to initiate the visa process until around mid-November time frame. So we should have plenty of time to review your file, give you instructions on how to initiate the visa process if that's relevant to you. Let me add, since we're talking about the application process, that as I mentioned at the outset, we encourage applicants, if they have an alternative program of interest, if they're interested in more than one program that we offer at Northeastern, we always have to say that every program is different, every program has a different set of admission standards, and every program has a different capacity for enrolling new students, and it's a highly competitive process. So a student can, apply to more than one program if they have such interest, but admission to one program does not guarantee admission to the other. Students who apply to more than one program may be denied to both programs. They might be admitted to both programs or admitted to one and denied to the other. So if you have interest in more than one program at Northeastern, we encourage you to take advantage of our alternative application offer. Instructions went out to many applicants about 2 weeks ago on how to do that. So if you have interest in that, please send us an inquiry. We'll share with you in the chat window a place where you can send us inquiries if you have questions following our session today. Since it's just past the top of the hour, let me conclude our session today by thanking you for joining us. On behalf of Dr. Bugrara, we gave a very informative overview of the program. I'd like to encourage you to attend other webinars that are scheduled. We have a session on our Silicon Valley campus tonight. We'll have another session on our energy systems program tomorrow morning. And we'll have another session from Dr. Bugrara on Thursday regarding the IS program, where we'll be talking a little bit more about the Silicon Valley option, the option to pursue a program in Seattle. All of these programs are slightly different depending on if you study in Boston versus other places. So we encourage you to gather as much information as possible by attending those sessions. A lot of students will have detailed questions about the cooperative education program. There's a separate webinar session on that. We'll continue to send you recordings of the sessions that we do, and we'll also continue to send you invitations and reminders for you to attend. So once again, congratulations to you if you're already admitted to these programs and you're already making plans to attend. If you're awaiting your decision, we wish you the very best of luck in this competitive admissions process. But we hope that you're very excited about the prospect of receiving your official decision, and if you're admitted, we hope you're excited about the possibility of joining us this spring or this fall. With all that said, I wish you the very best of luck and have a very wonderful rest of your day. Thank you.